Okay, now that we're a little more familiar with series and sequence, let's just go over some rules that'll help you kind of simplify things when you're working through them and whatnot. So, first is the addition rule. It basically says if you have if everything's indexed the same, and by indexed I mean we start at the same term, we can go ahead and add these together. Okay, and so in this case, if the sum of sequence A sub k and the sum of sequence B sub k equals the sum of sequence A plus sequence B, okay? And the sum of a sequence is a series. So we'll say series A sub k plus series B sub k equals the sum of both of them. We can just do a summation of them both, okay? So let me do a simple demonstration, okay? So let's say I have, let's do an easy one, okay? Because this is all just, arithmetic as usual, okay? So once you just get the concept, it's not too bad. So, all right, well, we know this is 1 plus 2 plus 3 plus 4, okay? And this right here, let's go k plus 1. Well, that's just, adding 1 to this one. So that's 2 plus 3 plus 4 plus 5. Okay? So let's add them together. Okay? Let's just add these together right here like this. So that's just going to be 1 plus 2 plus 3 plus 4. Okay, and that's 3 plus 5 plus 7 plus 9. And that equals 24. Okay? So now let's use, so that's kind of like the brute force method, but what if we just added these two things together? So what if we just said, okay, well that right there would be equal to, that would be k plus 1 is 2k plus 1. Okay? So let's go ahead and sum this up from 1 to 4. So I'm just going to write it down here. So that's 2, 1 plus 1. Ooh, I got too big. I think I'm going to run out of room. 2, 2. This is why I didn't use a high index of summation on here. Because they take a long time and they're kind of hard to fit. And did that fit on there? Kinda. So what do we end up with? 2 times 1 is 2, plus 1 is 3, plus 4 plus 1 is 5, plus 6 plus 1 is 7, plus 9, which was equal to 24. So yeah, it checks out. Okay, so we just demonstrated that it works. I wouldn't say this doesn't mathematically prove it, however, though. Okay, and we might do that later, and we need to use a principle called induction to do that, and we'll learn about that later. But you got to kind of master the series and sequence concept first. Okay, here's another good rule. This is the constant multiple rule, and basically, just like most algebraic expressions, we can just yank the constant out. Okay, so right here, check this guy out here. We got 2 raised to the power of k, okay, and then we divide it by 2. So let's just do it the brute force method. Plus 2 squared over 2, plus 2 third over 2, plus 2 to the 4th over 2. Okay, and that's just going to be what? 1 plus 4 over 2 is 2, 8 over 2 is 4, plus 16 over 2 is 8. So that's starting to look an awful lot like 15. Okay, so, well, this rule says that I can basically just yank out the constant, which is, and I can just go 2k, okay, which equals 1/2 multiplied by 2 to the 1 plus 2 to the 2 plus 2 to the 3 plus 2 to the 4th. Okay? So let's check it out and see if it works for us. So we got 1/2. So this is 2 to the first. It's going to be 2 plus 4 plus 8 plus 16. Okay. And that is 2 plus 4 is 6 plus 8 is 14 plus 16 equals 30. 30 divided by 1/2 is certainly 15. Okay, so this is a good rule. Okay, we can use this, and it can make your life easier. It can make it, sometimes it's easier just to go ahead and sum them up just as normal. So it just depends on the situation, but these are rules that you'll be able to do. So next, I think we're going to go over a couple little formulas and sort of tricks that can kind of help you do some of this without having to write so much arithmetic down. Okay? All right. Thanks for watching.